let's take a look. Let's take a look at the lab reports there. I'm going to start sharing my screen as well. You can see. Yeah, I will start sharing the screen. Hang in there. And what did I write here? I have notes. Okay. Today's schedule. We have the second lab schedule, right? We have the second lab schedule. But there's also lab report due. Lab report 1. Report for lab 1. Report for lab 1. Please upload the spreadsheet of the report of lab 1. Okay. And let's take a look there at my Google Drive and let's see how. You don't have to worry about the Word document yet because I only covered the spreadsheet, right? And next time, I will walk you through the Word document for the. Oh, wait a minute. Let me see. Let's go. Let's go there first, right? And talk about the Drive, Google Drive. Here you go. 2022 fall folder, Physics 6 group folder, right? Group 1. Yeah, here you go. Group 1 has a lab report here. 8:53 a.m. Today. That's good. Let's see group 2. Yeah, group 2 also has. Yep, they uploaded. Couldn't load user. 11:07 p.m. Might have been yesterday, right? 11:07 p.m. Let's see group 3. Yep, October. Okay, this one group 3 doesn't look like group 3 uploaded. Or did they? Yeah, it looks like they did because owner is Joshua. Good. Group 4. Yep. Group 5. Yeah, group 5 has no lab report there. Group 6. Good. Students in there. Group 7. Yeah. Looks like group 7 did because it was last month by 10:11 p.m. It's kind of a strange time, right? Why is that p.m. and doesn't say which day it is? Let's say group 8. Yeah. Group 9. Yeah, 8:53 a.m. Yeah, that looks like almost everybody. The only group that didn't was that group 2, 3, 4, 5, right? Group 5 didn't upload. Okay, group 5, make sure you get your spreadsheet in there. And lecture notes, lab notes. Okay, so please upload the spreadsheet of the report of lab 1. Okay, remember that there is still a hard copy, which I'm not asking you to do that for this first lab, but I'll be start asking you to do that for the second lab. Okay, there's a hard copy report for the labs as well. Okay, and I want to go through that right now. It's something very simple, and I want to go through that right now. Okay, so here we go. By the way, regarding lab 1, okay, here we go. I will correct this spreadsheet and upload it to your group folder. Next week, we will discuss all this process, okay? We will discuss that. Right now, this hard copy will be You don't have to submit this hard copy, right? Hard copy. The hard copy report is in reality a Word document. A Word document. You don't have to submit this Word document for lab 1, but it will be required for lab 2. Okay, for lab 2. Go. More people are joining us. Let's go through that. Let's go through this. Let us go through this Word document report. Okay, and we're gonna get, that's the syllabus. I described here in the syllabus what's the format of this Word document, and I'm gonna do that right on the spot for you. Okay, it's not that complicated. Okay, so here you go. It's a lab report format, must be prepared in Microsoft Word and upload to your group folder. In addition to the spreadsheet, there is also this Microsoft Word document, which will be also be uploaded to your group folder, but just for lab 2 on. Okay, we don't have to worry about lab 1. I recommend you to use Times New Roman, size 12 or larger, in the part of the documented format will affect your final grade. Okay, so let's go ahead and here you go. Here's your document, your Word document, the so-called what I call the hard copy, right? Go ahead and you create a new document. By the way, you have to save this document in the same format as your spreadsheet. You save this document in the same format as your spreadsheet, and okay, save as. I'm gonna put that right in here. Now, how is going to be the format of your hard copy report? It's going to be P06, right? Lab, the next lab is going to be 02. And then you put your group number, whatever it is. Same title. You can do that. You can have 2 documents with the same title, provided they are different formats. You're going to have one document just like that in Excel format, and another document like that in Word format. Make sense? Okay. So you go ahead and save it. And you're going to follow the instructions there in the syllabus. So let's go here in the syllabus. Going back to the syllabus. Syllabus. At the top of a single title page, center justify the following information. The following information, here you go. Separated by a carriage return. Okay, here you go. So let's go back to my document here. Physics laboratory lab report. Okay, center justify. Okay, right now I'm left to justify it. I'm not center justify it. That's why my cursor is right here. But if I center justify my document, the cursor is going to go right to the center of the page. I suggest you that you use Times New Roman and font size at least 12. At least 12 font size. Okay. Physics. Let me go back to the, no, not this one here. The syllabus. Okay, I'm gonna copy that and paste in there so I don't have to go back and forth. I'll have to correct something. Not this one. Two notes, this one here. Right? Here you go. So what's going to be the first line? The first line here is going to be physics laboratory report, physics lab report, physics 6. Okay. So that's the first one. Then you're going to put here lab number. Lab, in the case, is going to be the second lab, right? Lab 2. Oh boy. Lab 2. Then you put the title of the lab 2. It's nice to put that. Okay, use the lab number and the title documented on the accelerated motion. Okay. Next, all separated by carriage return. Okay. Name of the students. Student name 1. Okay. Name of the student who performed the alphabetical, who performed the lab in alphabetical order. Only those students that were present should be listed here. Okay. Alphabetical order by their family name. Right. Here you go. Last name. Here you go. Last name, first name, student 1, right? Student 1. Alphabetical order by last name, by family name. By their family name, not last, family. Family name, first name, student 1. Family name, second name, student 2. All right, you have at most 40 students in a group, right? Family name, third name, you know, the name of 30, you know, first name. Ah, okay, first name here. First name, right? Student 3, and so on. Very simple, nothing fancy. First name is student 4. So we did that. We did this one here. Next, name of the student who performed. Okay, let's see here. Laboratory number and title. Yep, laboratory number and title. List of the, and then group number. Group number. Group number. You know, X, right? Doesn't have to be bold-faced either. Okay, that's the first title page. That's the title page. And then, you know, insert, next page, third page. Prepare a table with the original data and any results. The table must be neat and well planned so the data can be easily grasped. Include the proper units and significant figures. Okay, so all you have to do here is to copy whatever you have there in your spreadsheet. Okay, let me give you an example from the labs that have been uploaded there. Let's look at the group 1, right? Here you go. Here you go, group 1. Okay, so here you go. You have how many tables you have here? We have 1, 2, 3, 4 tables total. So you go ahead, go to your spreadsheet, copy this table, each of those tables separately, and paste there. But it's not, you know, not just copy and paste. You also have to, you might need to edit this table so it looks nice in the document. Okay, so here you go. You might want to make a little bit smaller, right? First table, right? Then the other table. And if you have to do any editing to make it look nice, go ahead, do that. Next table. Here you go. we are going to, this table is going to be very large, so we are going to copy it little by little, okay? We're going to copy that little by little. Here we go. Copy this one. Okay. Vernier caliper. You, like I said, you can edit this table, shrink it. Oh, wait, this one is not moving. Yeah, here you go. Now it's moving. Good. Spend a little bit of time doing that. Okay, micrometer. That's the first part of the second table. Going back here, ruler. Hopefully we can fit everything. Next one here. Don't paste the table. Don't let the table be split into different pages. Okay. Make sure the tables are not split. A single table is not split into different tables. Page break. Go. Vernier caliper. Ooh. Here you go. Another one. This one here. That would be, next page. Prepare a table with the original data and results, right? You know, table. And another one. This one is very important because it tells us how close your data. See, your data here was 58% far away, but we covered that before, right? There was a reason for that. See, a very high percentage difference here. Did you notice that? But that's okay because it's the ruler, you know. But the other ones are pretty close. We covered that before last time. Here you go. Those are the tables. Okay, prepare a table with the original data and any results. The table must be neat and well planned so the data can be easily grasped. Include the proper units and significant figures. Now, very important is the graphs. Whatever graph you have in your spreadsheet. Okay, you're going to copy and paste in there. I noticed that this graph here doesn't have, right, this graph here is missing the regression equation. And also notice that those numbers here are zeros. They're not supposed to be zeros, right? So they're supposed to be placed in scientific format so the zero doesn't show up here. Okay, graphs. One graph. Graph one. Graph two. Don't include this thing here. Okay, don't include that. Let's see. Okay, here's the same, right? Do not include that. Just the graph itself. Okay. The label should be V for volume. Okay. Here you go. Graph. What else? error analysis, if any. Error analysis, what's the error analysis? The error analysis is basically those two tables, this table here that you see, and this other table too. Okay. They are part of the error analysis. So, and answers to any questions when asked. Okay. This part here, you don't have to worry about because this applies only to actual labs, okay? So I'm going to correct that in my syllabus. Okay, answers, error analysis, many questions. That's at the end of the reporting to this kind of version. Yeah, that doesn't apply to you. So I'm going to erase it. And that's how you're supposed to label. And by the way, it's not P37, it's P06, right? P06, lab number, group number. And upload that to your group folder. You know, I'm going to put here YY, right? Depending on the lab number. That's going to be version number 9 of our syllabus. So that's what you have to do for lab number 2. There is a document. You're going to save it. Let me erase that. And save it in your hard drive. Okay, yeah, already have a file named that. And then you upload this file together with the spreadsheet. Any questions about that? That's going to be required for lab number 2. Okay, it's not required for lab number 1, but this so-called Word document is going to be required for lab number 2 on, from lab number 2 on. Let's write that down here. Okay. Okay, this Word document will be required starting with lab 2. So next time you upload both the spreadsheet and the Word document, and this Word document. The so-called hard copy. Okay. That's what I want to share with you. And I'm going to upload a sample of this document there to the file, right? Let's here you go. Let's go through that again. That's a title page, you know, tables. Let's label that tables. Tables, graphs, graphs 1, 2, and 3, and basically that's all. Most lab reports won't have the error, won't have those other two. That other, here, not this one. Let me go to the here. Most lab reports won't have, all labs report have an error analysis, but you don't have to put that separately, okay? So the percentage difference is part of the error analysis. The CL is part of the error analysis. Most lab reports won't have, you won't have to answer questions either, okay? So basically there's 4 items. This item here is going to come together with the tables. So that's what we have. I'll go down there and upload this document. Yeah, this one here. Okay. To the shareable folder. Here you go. Right here. Sample, right? This is a sample for the hard copy. Put that. I'm gonna. So you got the idea, right? Sample. I'm gonna put it here. Rename. So you know we're talking about a sample. You don't write sample there, okay? In your actual document. And now we can start talking about today's lab. I'm gonna upload the data for the second lab. Okay, group 1, you have the data there for the second lab already. Group 2, you have the data. Group 3, group 4, group 5, group 6, group 7, group 8, group 9. Okay. Go, so good. What you have to do now, lab notes. So download the spreadsheet for today's lab to your hard drive. And let's see what this experiment is all about, right? I have a very short video that I upload in the past here in my Google, not my Google Drive, my YouTube account. And let's watch it, little by little. I have most of those videos there. Many of them are only at most 20 minutes long. Some of them are longer, okay, because I didn't edit them, but a few of them they're only they're very short, like this one. This one right here, for instance, is I'm running out of space here in my screen. So let's play it. The experiment consisted of demonstrated that the Torricelli equation. That was the goal of this experiment. Okay, I'm going to write that down here for you. You go lecture note, lab notes. Okay, today's experiment consists of demonstrating the Torricelli equation using a cart that is uniformly accelerated. What's the Torricelli equation? Let's write it down here. Insert. Here you go. Gotta get this guy here. The Torricelli equation is like that. V square. We derive that equation in equal to V naught square plus 2A delta X, like that. Okay. And what we're going to do in this experiment, we will determine the final velocity of an accelerated cart. But when I mean determine, it's going to be a result, okay? Verifying, okay, here, not demonstrate, but verifying the Torricelli equation using a cart that's uniformly accelerated. So continue number this. So the experiment consists of verifying the Torricelli equation using a cart that's uniformly accelerated. Okay. So we will determine the final velocity of the cart from our measurements. The final velocity of our car. Okay, B, using the measurements for delta X. We will determine the acceleration of the cart. Okay. By the way, the initial velocity of the cart will always be zero. It's always zero. Okay. V naught here is going to be always be zero. Then to find the acceleration, what do we do? We will plot V square along the y-axis and delta X along the x-axis. Note that V square is going to be my y, right? V square is going to be my y. And my delta X is going to be my X. So what we're supposed to get? We're supposed to get a straight line with a slope equal to twice the acceleration. And an intercept that should be very close to zero because the cart was initially at rest. V square and delta X. Também. That's how we are going to do that in the experiment. Let's take a look at our video. And here's a description of the experiment, how it's performed. Okay, so let's see here.
Okay, that's September 23rd, 2021, accelerated motion, inclined track.
Okay, inclined track.
Inclined plane. So this experiment, we're going to get a track.
Here you go. This is the equipment that we use for this experiment. It's an actual equipment. Okay, it's a aluminum track full of holes along this aluminum track. There's a reason why we put holes in this track. Okay.
Put on a table. Okay. Measure the distance between the point of contact of the track with the table.
Notice that we have a track here. This track has two legs. Okay. And what we do in this experiment, we first measure the length of the point of contact of the track. We need this data to perform the experiment. And then we get our cart and measure the length of the cart. Let's take a look. Let me I need to follow with you with the. While we do that, make sure you get the spreadsheet, right? Here you go. Here's the spreadsheet for lab number 2. Okay. Notice that we have this first table here with the acceleration of gravity that we already know is a data that's given to you. Okay. The goal of this experiment is not only verifying the Torricelli equation, but also to confirm that the acceleration of gravity that we get is close to 9.8 meters per second square. So the first thing that we did according to the video is that's to measure the distance between the points of contact of the track. Okay. B. The next thing that we do is to measure the lengths of the cart. We are going to need these 2 pieces of information. You're gonna see why. Not only in another piece of information too that you're seeing here. Here you go. I'm gonna continue playing this video.
You're gonna get a cart and measure the length of the cart. And we're going to use a shim and measure the shim with the micrometer.
Okay, so what's the shim? A shim is just a little piece of a piece of metal that has a given thickness that we use to raise the cart. Okay, so at this moment, what we have right now, experiment steps, experimental steps. 1, measure distance between points of contact of the track with the ruler. So at this point in time, you should already know okay, so remember your Excel spreadsheet is in your group folder, right? Everybody got the Excel spreadsheets? Okay, which group are you, Lydia? Which group are you? Group 8. Okay, so you should have the link for your group folder, and you can download the spreadsheet from that link. Do you have the link for your group folder, Lydia?
Yes, I do. I'm looking at the folder and all.
Yeah. Let me see. Let's see your group folder here. My screen is very busy. It's difficult, a little bit difficult to navigate. Let me see. A group folder. Yeah, see? Lab 02G08. Okay, Lydia, it's in there? Okay, good. So here we go. And let's go back to the lab notes. Okay, measure the distance between points of contact of the track, the distance B with the ruler. At this point in time, you should know, right, that the resolution of the ruler is what? X meter. 1 is 1 millimeter. And then that's how you're supposed to display the measurement of B. Measure the length of the aluminum cart that we use, okay? That we use. That's the length of the aluminum cart is L, and that's with the ruler. Okay. And going back to the spreadsheet, distance between point of contact, length of the cart. Don't forget to put the units here. Both measurements are made with the ruler. And then this measurement here is a little bit special because we use it to, we measure it with a micrometer, okay? Okay, we're gonna have attendance. I'm gonna take attendance very soon. Just bear with me. Let's go through this this procedure, right? Experimental procedure. So lab notes. Next, measure the height of the shim, of the provided shim. Provided shim. The shim is used to raise one side of the track so the cart can be accelerated along the incline, okay? Right, the height of the provided shim micrometer, right? Shim, this height is H. What is the micrometer? The micrometer is what? Is 1, 2, 3, 1, 2, right? 5 decimal places. 5 decimal places. Going back to the video here. Track, cart, shim. We need all those measurements, B, L, and H.
The cart you measure with the ruler, the track you measure with a meter stick. All those two values, B, L, and H, you log in your spreadsheet, in the first table of your spreadsheet.
Notice that I even show the spreadsheet for you, right? In the video.
So, Z, L, and A. Don't forget to put 9.8 there, no? In the next step, we connect the hose to the end of the track.
Okay, I provide you a hose as well. I provide you a hose that's connected at the end of the track. The hose has a function there in the experiment. Okay.
And the pump to the hose. Connect the pump to the power. And don't turn the pump, don't turn on the pump yet.
Okay, so what this pump is? This pump is an air pump. You know, that does the job opposite to that of a vacuum cleaner, right? A vacuum cleaner sucks the air, right? This air pump, instead of sucking the air, it blows the air. It blows the air through this hose. And this track has a bunch of holes here that allows the air to go through those small holes to levitate your cart. What this experiment is very, what the setup is, the setup is very similar to that air table that we see in the arcades, okay? It just happened the table is a two-dimensional object with a bunch of holes in there that air goes through and levitate your puck, right? In this case, it's not a two-dimensional table, it's just a one-dimensional track that levitates the cart that you put here over the track. We do that to eliminate friction between the surface of the cart and the track.
Now you turn on the pump. You
Wait.
get the cart put over the middle of the track. Make sure the cart moves without friction on the track.
So this is an important detail when you perform the experiment. So once you put the cart there at the top of the track, the cart will be able to move freely with no friction on the top of the cart. And then what do? We level the track. Okay, it's possible to level the track to make sure that surface is horizontal and observe the cart, whether it's accelerating to one side or not.
If there is any friction there, either the pump is not strong enough or there is something else going on. Level the track. You can level the track by adjusting one of the legs of the track and place the cart on the middle of the track and make sure it doesn't move along the track, doesn't accelerate along the track. If it does accelerate, then you adjust again one of the legs of the track to make sure it becomes level.
There you go.
Remove the card. In the next step, put the shim in one of the legs of.
Okay, that's the shim that we measure the height. This, we put the shim below the leg of the track to ensure that we have an inclined plane and the cart is going to move in an uniformly, in an accelerated fashion.
This track, right on one of the side of the track. Become familiar with the photo gate that's given to you.
Okay, so we have, I'm going to make a list of the devices that we have for this experiment. Okay, so you don't get lost. Here you go. Lecture notes, lab notes, right in here. We have the following, maybe we already have it here. Let's see. Oh yeah, here you go. We have the following equipment. That's the equipment that we have. You already saw air track. You already saw the air track, the glider or the cart, an air pump. You saw the air pump there in the drawing. You saw the hose. The hose was introduced before the air pump, right? And the shim was introduced before the hose and the pump. So that was the first one that was introduced, the glider, the shim, the hose, the air pump. Micrometer, the ruler, in addition to the ruler, we also use a meter stick that has the same resolution of the ruler. The meter stick is used to measure the length B, okay? And then we have this special device that's called a photo gate. Okay, this photo gate is a timekeeping device. It's a timer. And it's sold out there. Let me show you one photo gate for you so you become familiar. Most of you haven't seen that, right? If you haven't worked photo gate, timer. Precision photo gate, Pasco. Okay, let's see. Welcome to Pasco. Photo gate. Here you go. That's how the photo gate looks like. Okay, it's like a gate. And see here an example of a cart. When the cart goes through the photo gate measures how long it takes for the cart to move through the gate. Okay, the photo gate is a timer. Let me write that down for you. Which, by the way, it has a resolution. Photo gate is a timer, right? Photo gate is a timer with a resolution of a tenth of a millisecond. Okay, that's the resolution of the photo gate. So every measurement that we do with the photo gate is going to have 1, 2, 3, 4 decimal places there. Okay. So this is the equipment. Let us have a little break right now because we're almost doing that for 1 hour. Before we go for the break, I'm going to take attendance now. Today is the 12th. Any questions about that? Okay, so Vanessa, are you there, Vanessa?
Here.
Okay, you have the spreadsheet there, Vanessa?
Yes, I do.
Okay, good, thank you. Makin Curto, are you there? Okay, good. So if you don't say anything, I'm going to assume that you have the spreadsheet, that you downloaded it. Yeah. I'm gonna go there. Fisher Dawn. Are you there, Fisher? I see Fisher here, but I need you to tell me that you are present, Fisher. I'm gonna put a star here.
Professor, this is Lily. Quick question. So the 5th of October, I wasn't here and neither was my cousin because we told you it was our holiday. It was the
Mhm.
fast day. So do we still get 0 for attendance for the 5th?
Well, you know, let us finish it here, then we talk about that. Okay, let me, so you can go in the break. Come by during my office hour and we talk about that. Okay, Lily?
Okay.
Okay, Brian, let's see, Blessing, are you there, Blessing? I see Blessing in the list, but not answering. Here go, Blessing. Janet Garcia. Janet, I need you to be there, present. Oh, here you go, thank you. Next is Wendy.
Professor, I'm here. My mic was messed up.
What's your
Blessing.
name?
Blessing.
Okay, thank you. Next is Ryan Ong. Are you there, Ryan?
Yes, I'm here.
Okay, thank you. Okay, Ryan. Mia Villalobos.
Here, Professor.
Thank you.
Professor, I'm here right now.
Raymond Garcia.
Fisher.
Okay. Now Donovan's not here. Joshua Jimenez. Are you there, Joshua? I don't see Joshua here. Good. And Luis Latisa. Luis Latisa. Are you there? I don't see Luis in the list. Lily is here, right?
Yes, I'm here, Professor. Michael's
Okay.
here.
Michael, are you there? Yeah, Michael is here. Daisy Mariscal.
I'm here, Professor.
Thank you. Donish Chaparral, right?
Here.
Thank you. Ana Lopez. I don't see Anna here. Anna, are you there? I don't see her in my list. Okay. Yeah. And Mary Okiki. Are you there, Mary? I'm gonna put the star here on Mary's. Jennifer Pettis. Jennifer. Yeah, I don't see Jennifer. Elika.
Here, Professor.
Hi, how are you doing? Thank you. Next, Bethany.
I'm here.
Thank you. Artur Pacheco. Hi, Artur. Make yourself known that you're there in front of your computer. I see Artur here in the lists. Okay, thank you. Pedro Ruiz not here. Brianna.
I'm here.
Thank you, Brianna. Basilio Lopez. Thank you. Vahag, Mark.
Here.
Alejandra Marmolejo. I don't see Alejandra. Amarilis Mejia.
Here.
Thank you. Yesenia Montes Rodriguez. Good, thank you, Yesenia. Leibelud. Thank you. Lydia Rosas Buenrostro. Thank you. Justena Youssef.
Here, Professor.
Jade. Ashley Diaz.
I'm here.
Thank you. And we have Erica Fajardo. Are you there, Erica? I don't see Erica here. And let's see how many students we have. 24. Okay. Okay, good. So it is 9:50 right now. Let's go for our break. Break until 10:05.
Professor, I'm here.
Who's that?
This is Fisher.
Fisher. Okay, thank you. And Fisher right here. And there is also another student. I want to give him the Mary, right? Mary, are you there? I want to give her the opportunity. Yeah, Mary's not answering. Okay, so let's go for our break. Okay, break. From 9:50 a.m. to 10:05 a.m. I'll see you in the next 15 minutes. If you want to, in this meantime, if you want to review the video there that I have online, that might help you as well. Okay, so see you shortly.
Hello, Professor. Hello? Hello?
Yeah,
Professor?
is that Mary? Is that Mary?
Yeah, that's Mary. I didn't hear my name, Professor.
Okay, here you go. Let me give you attendance here. Thank you, Mary.
Thank you, sir.
Okay, let's see. I'm back here. Okay, so let's go back there to our video. Right now, let the video play. Okay, out at the very end, and then we can start working on the spreadsheet. Here you go.
Good. You have to understand how it works. Photogate is a timer device. Place the photogate in the opposite leg of the track in the inner side of the opposite leg. And measure the position of the photogate with the card. Okay, consider the position of the photogate. Consider there is an x-axis along the track, and the track itself also has a tape, a calibrated tape in meters, in centimeters. So this position of the photogate.
So this track, in addition to have all those holes in its surface, it also has a tape measure along its length. Okay, that you can look at the position along the car, along the track.
Is going to be known by placing your card just before the photogate. When the light of the photogate turns on, you can measure the position of the front bumper of the card in the tape, on the tape.
Okay, so what we have here, we are measuring the position of the photogate. We need to know the position of the photogate because we are going to release this card from different positions here along the track itself. And the photogate works in the following way. It has that configuration, right, that you saw before. It's like a mouse, right? It's let me show again the drawing, the illustration of the photogate, right? Photogate, here you go. Here you go. It has this configuration here. In this photogate here, you have a little infrared light, and also you have a detector. Just like you have, this thing works just like your remote, okay? Your remote there. Your remote has also an infrared light, and then a detector as well that allows you to change channel. In this case, your photogate behaves slightly different. It is even simpler than your remote, your TV remote that you have there. The way it goes that whenever the card crosses this light beam, this infrared light beam here, it starts timing. And whenever the light beam, and whenever the card passes completely through the photogate, the timer of the photogate stops. That's how the photogate measures the interval of time. And by dividing the length of your card by the time measured by the photogate, you obtain the velocity of the card. Okay, that's how we measure that. So what we are doing here in the experiment right here, we're measuring the position of this photogate that I call it Y, just by approaching the card and observing the photogate whenever we trigger the photogate, okay? And the position Y is documented, not here, here you go, this one here. The position Y is documented here in this table. We make like 5 different measurements of this position Y. We sum them all, right? And take the average. Sum here, here's the sum, and then take the average of the sum. Just put the card in there, measure the position of the card, the front bumper with respect to the ruler, take it out, put it back, take it out, put it back 5 times. We do that 5 times.
Tape on the track. Do that 5 times. Next, choose 10 different positions that I'm going to call X1, X2, X3, X4, until X10, from which I'm going to release the card
Okay, so what we are doing here, we got the position Y of the photo gate, and we are going to release this card from different positions that we see here. Here is X1. This other one here is X2. This is X3, 4, 5, 6, 7, 8, 9, 10. So what's going to happen? You're going to release the card from rest. The initial velocity of the card is going to be 0, and it is going to accelerate along this track. When you release the card from this position, the velocity here at the photo gauge is going to be the highest one of them because the card had a longer distance to accelerate, okay? And that was the other table is all about. Let's take a look at the other table. Here you go. Position of the photo gates, 1, 2, 3, 4, 5 measurements. And here is the initial position of the cards. X1, X2, 3, 4, 5, 6, 7, 8, 9. We have like 10 measurements. Okay, measurements 1. Let me put that here. I don't want the number without decimal places. Okay, measurement 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's what this thing is supposed to be. Here you go. Measurement number 1. Measurement number 2, 3, 4, 5, 6, 7, 8, 9, 10. It's better in this way. X is going to be the position of the photo gate of the card, the initial position of the card. Okay. D, is going to be X minus the position of the card, the distance that the card traveled. And V is going to be the length of the card right here, right? You can see the equation. Here you go. V is going to be the length of the card, L, divided by T, the measurement by the photo gate. V square is going to be the square of that, and so on. Okay, so let's finish it.
And measure how long it takes for the card to move through the photo gate. Make sure that the photo gate height coincides with the top of the card. So you release from X1, record the time, and record that on the third table. The second table for the position Y. In the third table, we are going to record the time and the position of the card.
Initial position. Don't forget, that's the initial position, right? I said position, but actually it's the initial position of the card.
Finally, you plot V square against D, which is the difference between the position Y and the initial position of the card, X, big X. It should be a straight line like that. Works very well.
Okay, so now you start the experiment. Now we are going to plot the graph of the experiment, right? V square. Here you go. V square versus delta X. My delta X in the formula, I call it D here. Okay, notice that D is this value here minus the position of the photo gate. Or let's say the position of the photo gate minus the initial position of the card. So if you go ahead, that's the first thing you're going to do. Plot the graph, right? Here you go. You get a nice straight line. Here we have V square. Here you get delta X. This slope that you see right in here of this curve is going to be equal to 2a, twice the acceleration of the card. Okay. Let's try to finish now. Here you go.
So that's the experiment, illustration of the experiment, right? So the 10 position.
So notice that when I release the card from here, right, which is the longest distance, the kart is going to accelerate to a speed, a given speed, v1. Okay, because it's going faster than the other position that you were releasing the kart, the delta t that the photogate measure is going to be smaller compared to all the other ones, right? If when you release the kart from this position right in here, the delta t measure is going to be the longest of all. Because the kart is, although it's accelerating at the same rate, the final speed here is going to be lower than the speed of the others.
If everything works, if you have good data, what you're going to do, you're going to log the slope of this graph on the last table. Right in here.
Okay, so here you go. Let's take a look at this slope, right? Let's take a look at the table there. That's once you get the slope of the graph, you log it right in here. This slope is what? Twice the acceleration. Just like we saw in the notes. Here you go. Here's the slope of my graph, right? Here's the slope of my graph. Then you solve for A to get the actual acceleration.
And if you got a good result, this delta that you see right here is going to be very small, less than 5%.
By the way, this acceleration here is related to the acceleration of gravity. There is a relationship between this acceleration that we find, okay, and you can see the equation there in the spreadsheet. So if your measurement of the acceleration are good enough, you're going to get a value for the experimental acceleration of gravity that's going to be very close to 9.8, and your delta is going to be small.
Okay. So let me stop the recording, and now this one got 6 minutes, right? Go. Okay, we're recording right now. And that's September 23rd, 2000.
Oh, that's another video for the experiment. So let's stop here. Okay, good. So now we can start doing the actual job. Okay, so let's see one by one. I want you to remember. I want to plot, right? V squared versus B. Let's plot the graph first. Lab notes. Okay. Okay, plot. Plot graph V squared versus D. D is, just your delta X in the equation. Log the slope of the graph in the last table. There you go. In the last table. Look at the acceleration value, and the acceleration value A. Look at the acceleration of gravity G obtained from A. Right? So let's go one by one here. I'm gonna see if okay, Vanessa Bonilla, did you get your graph plotted already, Vanessa?
No, not yet.
Okay, do you have the spreadsheet there?
Yeah, I do.
Okay, good. Makin? First, you have your spreadsheet, Makin, and we plot the graph. Did you plot the graph already? I don't hear from Makin. Okay. Okay, I'm gonna put here a question mark. Fisher, did you plot your graph already, Fisher? I don't hear from Fisher either. Blessing, are you there, Blessing? Okay, so my goodness, let's see. Group one, okay, I don't hear from Blessing. Janet, are you there? I'm gonna keep on checking with you, now and then, see if you're participating, okay? Janet, I can't hear. Okay, good. Did you manage to plot the graph, Janet? Okay, good. Okay, for now, I'm gonna put, say that you didn't plot the graph yet. Okay. Do you need any help? What's the problem you're having? Just tell me what the problem you're having so I can help you out. Okay, good. So you're plotting right now. Wendy is not here, right? Ryan Ong, are you there? Ryan?
Yeah, I'm here.
Did you plot the graph already?
Yes, I did.
Okay, good. So what's the slope that you got?
Oh, I didn't get the slope yet. I'm gonna do that right now.
Yeah, get the slope, and yeah, if you plot the graph, don't forget plot the graph, get the regression equation, and get the R square, right? And once you get the slope, you log it here in the last table. Mia, are you there?
Yes, Professor. I'm still working on it.
Okay, good. Okay, Raymond, did you manage to plot the graph? Yeah, not having issues. Okay, try to sort that out there with your spreadsheet, okay? Now, Raymond. Joshua, are you there, Joshua? No, Josh is not here. And Luis Latisa, not here either. Lily, did you manage to plot the graph, Lily? Yeah.
Professor, I'm still working on mine. It's my
Okay.
Excel's giving me a hard time. So.
Okay. So Michael, still doing okay. If you have any problems, if you need any help, let me know, okay? So I'll get back to you all, folks, before the end of the class. Daisy Mariscal, are you there?
Yeah, I'm here.
Okay, were you able to plot the graph?
Yes.
Okay, what's the slope you got?
I'm putting that in right now.
Okay. First you plot the graph, then you put the R square and the regression equation, get the slope, right?
Mm-hmm.
So
Just confirming that the V to the power 2 is the X and the D is the Y, right?
remember,
Or is it the other way around?
Let's see. Let me see what I put there. Is V square in the Y and D in the X. Okay, so let's see here if I get that. That's the lecture notes, lab notes. Okay, here you go. Plot V square versus D. Okay, has to be V square. V square along the y-axis and D along the x-axis. Okay. And the graph is already set well for you to do that, right? So if you go right in here, here you go. Right, you can see that V square is already to the right of D. So if you highlight those two columns, and there's a little trick, right, to do that. Here you go. Highlight this first column, press Control, and highlight the second column. You know, insert again. That's for group number 1, right? Straight line, and then click, right click, add trend line. Okay. Display equation chart, display R square. Okay. Who's next? Attendance here. Daisy, right? Just talk to Daisy, right? Now it's Donia. Are you there, Donia?
Hi, Professor. Yeah, I'm still here. I'm still working on the graph, though.
Okay. Let me know if you have any problems.
Thank
Anna,
you.
is Anna there? I don't see Anna here in the list. Mary, are you there, Mary?
I'm here, Professor.
Do you need help?
Still on it. No, I'm still on it.
Okay, still working on that. That's good. Next is going to be group number 5, Jennifer. Jennifer, are you there? Now Jennifer is not here. Elika?
Yes, Professor. I'm actually done with the graph and then I do have the slope.
Okay, good. What's the slope you're getting there?
I've got 0.2397.
397. Okay. The 397. And then good. So you can move forward. What percentage difference are you getting? Did you log there in the last table, by the way? Did you log the slope in the last table there?
Yeah.
Okay, what percentage difference you're getting?
Let me look at it. Nothing's coming up there in the percentage.
Yeah. Your group number 5. Let me get that here. Group number 5. See, open. Here you go. Number 5 here. Okay, again, what's the slope you get? You got 0.2. What else?
Sorry, I got 0.2397.
397. Okay, so you're getting, here you go. The acceleration ends up 0.1199, right? Because it's half of the slope. Okay, when you do the calculation for finding the experimental G, the experimental G is related to the acceleration that you find, and also it's related to B and H, okay? If you go back, see that B and H, there's a relationship between them to find G. When we do the calculation for G, you find this value 9.3, which corresponds to 5.02% only. Okay, don't forget, if you don't see that percentage difference, make sure you have the G 9.8 right in here, written down in your first table. Okay. Okay, I'll get to you, McKeon. Thank you for letting me know. Then gotta finish the rest, right? There's a little bit more that we have to discuss. First is remember, this is a uniform accelerated motion experiment, right? Material related to uniform accelerated motion. Now, what about Bethany?
I
Bethany,
got it.
you got it? What
Yeah.
did you get for the slope?
I got 0.2157.
157. What's the percentage difference you're getting?
Mm,
The percentage difference.
Where do you find
Okay, the
that?
percentage difference. First, you gotta put the slope here, right?
Uh-huh.
You log that here. When you put the slope here, you're gonna see the acceleration value, right? What acceleration value do you have?
That one I have 0.1079.
Okay, good. And what are you getting for the G experimental?
7.9889.
Wow, 7.9. That's a lot. Okay, it's gonna be a big difference. What about the delta? What you're getting for the delta?
18.4807.
Yeah, it's close to 20%. Okay, so you're group number 6, right?
Yes.
Let me check why you're getting such a big percentage difference. Okay, so you plot V square versus B, insert chart. Here you go. Oh yeah, see? That's the problem.
I
Nice.
noticed that too. Yeah.
Yeah, okay. That's the outlier, okay? So when the students perform this experiment, you know,
Mhm.
it looks like they didn't get a good data here, and they didn't, you know, when I'm doing the actual experiment with my students and see something like that, I just ask them to perform this, to repeat this point again. Now, let's see, I'm going to take away the how do you call it, is the outlier, and let's see if we get a better result, right?
Okay.
This outlier is skewing your slope. And by the way, that's something that we find in real life, okay? Either the outlier is an error, an experimental error, you know, a measurement that was not properly made by the student or the scientist. Most of the time it's like that, or maybe the equipment failed and give you a better, at that very moment, the equipment failed and then gave you a very bad measurement. Or maybe, you know, you discover something new that nobody else knows. That's very rare, okay? That's very rare, something like that to happen. But I'm talking about not just in terms of this experiment itself, but experiments in general. Nice thing about science is that whenever you discover something completely unexpected, okay? Okay, see what's happening here? Because of this outlier, your R square is very low, right?
Mhm.
It's not 0.9. Now,
Right.
and again, because of this outlier, you are getting a lower slope. This outlier is pulling your slope to the lower values, right? Now, if you remove the outlier, which one is this outlier? Let's see which one is this outlier. I'm going to. The problem is which measurement. The problem should be the measurement.
Is it 7D? Because it's like 8E.1. Is it that one?
Let's see. I gotta reformat this data. Okay.
Yeah.
We can see it more clearly. Let's put format cell number. When everything is in that format that I give to you, it becomes very difficult to see what's going on, right? And which one is the outlier? Let's see which one is the outlier. Okay, it's going down, right? It's going down. Yeah, it's going down. Good. So if it's going down, this one should be going down as well. Okay, the outlier is this one. See that? That's the outlier. Okay, now I'm gonna plot only the data, and I'm gonna exclude the outlier from my data. Yeah. So to see if we get a bet. Okay, now I excluded the outlier from my data, right? Trend line, display, blah, blah, blah. I'm getting 0.2485, right? And now my R square is better, right? So there's no longer that outlier is in there. I'm going to log the 0.2485 0.2485 down there, 0.2485, and bingo, 6% only. See that?
Yep.
So that outlier alone is, making your delta much higher.
Should I leave it or change the value?
Leave that, leave that. Leave that and remember that for the future, okay?
Now,
Remember-
whenever I do the graph, should I exclude the outlier?
No,
Or-
no, just keep it there.
Leave it.
Just keep it there. I'm not gonna punish you for that, okay? But this is a type of things that we find in real life, and keep that in mind for the future, right? When you're performing actual experiments, making money out of doing experiments, remember this day that we discuss outliers, because you may see outliers in real life. Okay. Okay, so now, good. Now, next one in line is going to be Arthur Pacheco. Are you there, Arthur? Yeah. Okay. I have my. Yeah, that's right. Okay, good. So did you follow the discussion that I had with Bethany? You and Bethany have the same data, okay, Arthur? So whatever I discussed with Bethany applies to you as well. Okay. Okay, and play a little bit with that graph. Do exactly what I did. Exclude the outlier to see if you get a better delta or not, right? But when you turn in the graph, just keep the outlier in there. Okay, good. So Pedro is not there. Brianna?
Yeah, I was able to figure it out.
Okay, good. So you're working together there, right, with the other students?
Yes.
Good. By the way, you plot the graph, right, Brianna?
Yes, I did.
Okay, good. Did you understand the discussion that we had?
Yeah, I did.
Okay, good. 216, okay. And next, Basilio. Are you there, Basilio? Okay, you got the graph. Okay, you're group 7, right? What's the slope you got, Basilio? 0.2463. Okay, how much percentage difference you're getting there? What's the percentage difference that you're getting between the experimental G and the actual G? After watching you run through the, I need to redo it. Okay, you need to redo it. Don't forget. Okay, so don't forget the percentage difference is right in here, right? The number I want to see that I want you to tell me is this one here, right? Once you put the slope here, it's going to display the percentage difference. Okay. So let's go to someone else there in the group. Bahag, did you plot the graph, Bahag?
Yeah, I got 0.245.
2.245. Okay. Okay, good. What about the percentage difference? What are you getting there for the percentage difference?
7.4.
Okay, 7.4. That's good. So your group number 7. Let's take a look there. I'm going to plot that for you. Just double check everything is 7.4%. 7.4%, right? It's a V square, right? D. You don't have any outliers there, right? Okay, yeah, no outliers whatsoever. Good. So click it, right click, add trend line, display equation, R squared. Okay, 2.536 that I got. Okay, you got 2.5 0.254, right? Which is surrounding 2 point, yeah, 2.2, sorry. Group 7, 0.2536, 0.2536, 0.25, yeah, I'm getting a different slope than you are getting, okay? Do you see that? 0.2536 instead of 0.24. I do not know why you're getting that value there.
Yeah, I highlighted all of D. That's why, because you did starting from resolution 2 for D. I highlighted both of them. I think that's why.
Yeah, you're supposed to highlight everyone, right? You're supposed
Yeah,
to
that's what I did. But I think you just you didn't do that for this one.
Check what's that. Check what's
Okay.
that.
Yeah, I'll retry right now.
Yeah, and then you tell me what was that. You know, check what's that and then tell me what happened. Let's go to the next student. Alejandra, not here, right? Amarilis, are you there, Amarilis?
I am still working on it.
Okay, thank you. Yesenia? Have you plotted the graph, Yesenia? Okay, okay, so I'm gonna put a 0 here for now. Labilut?
Yes, I got the graph, the slope I got 0.2476.
0.476 is like that? 2.2476, right?
Yes.
Okay, what's the percentage difference you're getting?
I'm still doing that.
No, you don't have to do, because once you log the slope here in the last table.
Oh, okay. Oh, I didn't know that because I was trying to find the slope first because the Excel didn't give me. Just 1 second.
Yeah, it's this last table. Once you log the slope right in here, all those numbers are going to show up automatically. I'm asking for this number here, the delta percentage difference.
Okay, so I log the slope here in units, and now my give me.
You worry about the unit later on. You don't have to worry about that now. Okay, just log the numerical value here. Let me know what percentage you get here.
Okay.
Okay, I'll get back to you. Okay, so I'll give you opportunity. Let's see. Not yet. Next, Lydia. Okay, so you got this low 0.2476. Okay, you're getting 5.9. That's good. 5.98. Okay, so that you don't have any, in your case, apparently you don't have any surprises, right? Let's take a look at your graph, at your values. Group number 8. You go V square, D, insert, chart, okay? Trend line. Nope, I need to put, I need more than that. Trend line, let's see. Trend line. Here you go. Okay, 0.2476, just like you told me, right? You go. 0.2476. Yeah, you round it up to 0.248. Now, number 8. Now let's write down this slope there, right here. 0.2476. 0.2476. So Now they allow 2 point. Oh, look at your experimental G, right? That's the acceleration value that you're getting. 0.1238 meters per second square. You're getting your experimental acceleration of graph 9.2. That's lower than the accepted value of 9.8. And you're getting 5.98, right? So is that what you told me? Yeah. So you got it right. Nice. Thank you. Let's go for the next one. Justena. You get your graph, Justena? Are you there, Justena? I'm going to put a question mark here. And next is Jade. Hi, Jade, are you there? Okay, 0.262, right? And the percent, okay, 3, good. Your group number 9. Let's take a look at the data of your group. Group number 9. Good. V square D insert. Here you go. Straight line, no outliers here. Add trend line. And display equation on chart. 0.2621 that I'm getting. That's what you got too. 0.2621. Yeah, that's right. 2621. Yeah, good. And log in there. 0.2621, right? Oh, you're getting only 3%. That's good. This data is good, right? So now we know more or less that at least for you folks, right? You know that our data works pretty well. Right? Let me quit it. Saving. Good. Now the last one is going to be where is it? Yeah. Looks like I lost my. Bears me here that looks like I accidentally closed my attendance spreadsheet. P06 attendance, no. Huh, interesting. Let's see. I want to quit everything so I can clear the. Now. Okay, F22 attendance. Okay, I'll get to you. Good. Okay. Ashley, are you there?
Yes, I'm here.
Okay, good. Did you plot the graph?
Yeah.
Okay. So you get the same slope as Jade?
Yeah.
Okay, good. So that's what you're supposed to get. Do you have any questions about that?
No, thank you.
Okay, good. So let's go back now to group number 4, right? Group number 4, Daisy Mariscal. She got 0.2621, right? Percentage difference 3%. Okay, good. Take some raw data, group number 4. Good. I'm gonna plot your graph. Okay. V squared D insert. Okay, here you go. No outliers there. You get, I'm getting 0.2621. That's exactly what you told me, right? Yeah, good. And if it's 0.2621, should be that percentage difference that you mentioned. 0.2621. Okay, 3%. Good. Thank you. Now you can proceed with, once you are done with the graph, right? Yeah, Michael, you're group number 4 as well, Michael. Yeah.
Yes.
Good,
Yes.
good. Yeah, since you're in the same group, yeah, you should get the same result. Good. What about the other groups? Let's see. Group number 1. Did you manage to do that? Group number 1. Anybody in group number 1? Vanessa? Vanessa, McKeon, Fisher. Okay, let's see. Vanessa, are you there? Okay.
I'm still doing it.
Okay. Do you need any help there? Oh, you have the graph and the slope. Okay, what's the good? McKeon managed, right? What's the slope you got there, McKeon? 0.2621. Huh? Okay, what's the percentage difference you're getting? Around 3. Okay, so let's double check here. Okay, I'm gonna save this one. Group number 1. This one here. Good. That should be group number 1. V squared D insert plot. Okay, no outliers there, no surprises whatsoever. Add trend line and display equation chart R squared. Okay, yeah, 0.2621, just like you told me, right? So it should be 3%. 0.2621. Yeah, 3%. Good. Now let me quit yours. Another one, another student, McKeon, right? Okay, Fisher, are you there, Fisher? I'm revisiting Fisher for the second time.
I'm here, Professor.
Okay.
I'm on my laptop, so Excel is actually not working very well right now, but I got a similar result.
Okay. Okay, so I'll put one here. Blessing. Thank you, Fisher.
I think I did it wrong, but I had a 2762, but the percentage was 3 as well. But I think I did it wrong, but I think it's the same as that one.
Did you get a slope of 0.262?
Now I had a 0.276.
0.276. Yeah, I do not know what you did. Make sure, try to replot it. You're group number 1, right? Yeah, your group number 1. Try to replot it. And also, interface with your classmates and try to figure out where's the mistake, right? Or just repeat it. Okay.
I used the wrong graph. My bad. I'm gonna do it again.
You got 2,762, right? Is that what you got?
To see if I get the right one.
Yeah, just report it. Let's see the other students. I'll get back to you, Blessing. Okay, I'm going to put a question mark on the slope. And let's see, Janet, did you manage to get the graph, Janet?
Yeah, I got the graph.
So what can you tell me about the slope?
For the slope, I got 0.9934.
934 sounds too large. Let's see, group number 2. Let's see what's the problem. Group number 2. Right in here. Okay.
Professor, I did it again. Give me 1 second.
Okay.
Okay, I got 0.2284.
Okay, so let's see, 2284. Let's check with the one I get now. Number 123 2284 V square D. Insert chart. I'll see. Did you see this data here? Who am I talking to again? I forgot your name.
Yeah, I did.
Yeah, it looks like this one is an outlier too, right? Interesting. Okay, but that's okay. This one is not going to affect much the final result because this outlier just a little bit off. It's not as much off as the other one is. Yeah, 22. Okay, yeah, you got the same. I got right 2288. Okay, what's the percentage difference you're getting?
I got 9.08, I believe.
Okay, 9%. Okay, so that's less than 10%. Your group number 2, Janice, right here you go. 0.2.
Yeah.
2288, right? 228 that you got.
Oh, it was 2288.
Yeah, 2288. Let's go back there. Man, it's so difficult to work with a single screen here. I keep on shifting my. Here you go. 0.2288. Yeah, 9.08. That's good. So you got it right. Now you can move on to the other things. All right. We gotta work on the units. Once you are done with the graph, and I'm gonna cover a little bit about significant figures, right? I'm gonna revisit significant figures. We cover significant figures for results for multiplication division, and then I have to talk to you about the significant figures of whenever you, how do you display significant figures whenever you sum and subtract. Let's see. That's Janet, right? Janet, good. 9%. Okay, and lab notes. Plot this. Okay, look at that story. Okay. Things from A. Look at the percentage difference. At the percentage difference. Preferably, in general, it will be less than 10%. Okay. After that, start working on the units of your measurements. Okay. So let's revisit the other students that didn't have opportunity to share with me. Let's see, group 3. Group 3, Raymond Garcia. Did you manage to? Did you manage? Are you there, Raymond? Oh yeah. Stuck. Okay.
Professor.
Uh-huh. Okay.
But this is blessing. I got 0.262.
Okay. 0 blessing, right? Which group are you, blessing?
Number 1.
Number 1. Okay. What's the slope you got again?
2.62 and 3%.
Okay, you got 0.262, right?
Mm-hmm.
Okay, just like the other student. That's good. So let's going back here to Raymond. Okay, Raymond, try to get your results there, right? And I'll get back to you. By the way, you're alone, right, Raymond? I see here that your group members didn't show up today. Yeah, okay, so you're on your own today. So when you turn in the lab report, only your name should be there, okay? So what about Lily? Do you have any questions, Lily? Did you get your graph plotted? I can't hear you, Lily. Okay, okay, don't hear about Lily. I'll put a question mark here. Michael? Are you there, Michael? Okay, Daisy, I talked to Daisy. What about
Yes, Professor.
Is that Michael?
Did you say something? Sorry, I was trying to unmute.
Okay, good. Did you get the slope of your graph?
I'm sorry, I'm having technical difficulties. What did you say?
Yeah, did you plot your graph? First question, right? Did you plot your graph?
Yeah.
Okay. What's the slope you got?
I got 3%.
Okay. You got 3%, you said?
Yeah, and it was 0.2621.
Okay, good. That's what you're supposed to get. Okay, good. Thank you.
Thank
you. So let's move forward here. Group number 5. Mary, did you plot the graph, Mary?
Yes, Professor.
Okay, good. So what's the slope you got?
0.263.
0.263. Your group number 5, right?
Yes,
So,
Professor.
okay, so let's get this. Let's plot that together. Group number 5. Okay, good. So here you go. You got a graph somewhat like that, right?
Yes.
Mary? Okay, good. So let's trend line. Display equation chart. Okay. Let's see. I'm getting 0.2397. And did I write that down here? Yeah, you said you got 0.263, right? Check your slope. That's not the correct result I'm getting, okay? That's not the result I'm getting. Okay, just like Elika, right? Elika got like 0.24. So check why you got this one. And
I got 239.2397, Professor.
yeah, just like me, right? Who is that? Elika?
Yeah.
Okay, good. Yeah, just like me, right?
Yeah.
Good. Okay, so most of you already got the slope and the percentage difference. So the next step now is to work on the units. I think the most fun part is getting the graph, right? Getting the graph is the most fun part of the experiment. And everything else is just detail, but it's still Lily 2621. Okay, Lily, let's see here. Let's see. Okay, yeah, just like everybody else, right? Thank you, Lily. 3%. Yeah, because you're on this. Because you folks are in the same group, you should get the same slope, the same percentage difference. Now, what time is that? 11:06 already. Let's take a little break, right? Yeah, Donia, you're getting the same answer from home with group 4. Yeah, okay. You is group 4 with Lily, and you're getting the same answer. That's good. So it means that you did everything right, huh? Okay. If you had different data sets, then you got different slopes. So 11:07 right now. Any questions before you go into a break? Everything else you know what to do, right? It's just getting, well, the only thing that you do not know is going to be the significant digits for the summation. And then I'm going to cover that after the break, okay? We cover significant digits for multiplication and division, but we have yet to cover significant digits for summation and subtraction. So you should be able to report the sig figs of V and V squared. You should be able to report the sig figs. What you do not know yet is how to report the sig figs of D and the summation and the average of the quantity Y, position of the photo gate. Okay, and we are going to talk about that when we return from the break. So it's break to break to 11:25 a.m. Okay. I see you in 15 minutes.